In this video, we will introduce Newton's third law of motion. Consider a person standing and pushing against a wall. If you've ever pushed against a solid wall, you know that you're applying a force and you can get tired if you do it for too long. But according to Newton's second law, an applied force will produce a net acceleration. However, in this case, the wall is not moving. There's no acceleration here. So what's going on? The answer is also found in Newton's second law, which says that the net force will produce a net acceleration. The fact that there is no motion here means that the net force must be zero. So if you're applying a force to the wall, but the net force is zero, then the wall must be applying an equal but opposite force back on you. This is the essence of Newton's third law, which states that for every action there is an equal but opposite reaction. Newton's third law can also be expressed in this way. If two objects interact, the force exerted by object 1 on object 2 is equal and opposite to the force exerted by object 2 on object 1. It is Newton's third law that enables two people to lean on each other without falling over. It is what enables a jet plane to fly. When a plane pushes hot air out of its jet, the exhausted air pushes back and propels the plane forward. It is what allows us to drive around in our cars. When the car's wheel spins, it is pushing against the road, which in turn pushes back at the wheel, enabling it to move forward. So forces come in pairs whenever there's an interaction. Without these action-reaction force pairs, it would be impossible to do anything that we are used to. Newton's third law states that whenever there's an interaction, for every action, there is an equal and opposite reaction. In subsequent videos, we will look at how Newton's three laws govern the everyday world and look at examples how these laws are applied to different situations.